topic today is on simple harmonic motion, and that will make us to revise the type of motion we have done in the past. And don't forget, we said when an object is moving on a straight line, we call it linear or translational motion. But when an object is moving about the axis of another object, we call it circular motion. But when an object is moving about its own axis, we call it rotational motion. What of object that's moving in a specified direction, that is in an irregular manner or zigzag manner, we call that one random motion. But if an object is moving to and fro, that is forward, backward, on a straight line, we call it what? Oscillatory motion. So our today's topic we base on one type of oscillatory motion called simple harmonic motion. Now, when we said oscillatory motion, we mean an object that moves in to and fro manner. In that case, we are less concerned about the relationship of the force and the displacement of the object. But in case of simple harmonic motion, we are dealing with the relationship between the force and the displacement, and as well as what? Acceleration and the displacement. In that case, there must be what? Fixed point called equilibrium position. Therefore, the force will serve as what? Restoring force that will take the object to what? Equilibrium position. In this case, the force will be varied directly with what? Displacement. Take note of this. The force, we are going to make use of it later. The force F will be varied directly with the displacement from equilibrium position. In this case, we are going to define our simple harmonic motion as the kind of motion in which the acceleration is directed towards a fixed point and is proportional to the displacement from that fixed point. What I mean is this: if you have an object like this, so if you displace this one, so if you release it from here, the force will be directed to this point, towards this point. And don't forget, the moment it gets to this place, it will not stop. It will still move up like this. So this point, let's say point A, point B, and C. This point A and C are called point of maximum displacement. Then we now have different form of this type of what? Simple harmonic motion. We can use simple pendulum bob like this to perform our simple harmonic motion. We can use loaded test tube on the water so that it will be going up and down. We can still use loaded spring as well. We can use cantilever to perform our simple harmonic motion. Our major objective there is that for an object to perform simple harmonic motion, its acceleration must be directed towards a fixed point, and it must be what? Be proportional to the displacement from this point, from this fixed point. Therefore, the higher the displacement, the higher the acceleration. The higher the displacement, the higher the acceleration. Then when we are now talking about simple harmonic motion, we have some terms that we need to mention. The first one is what? Amplitude. When we say amplitude under this simple harmonic motion, we mean maximum displacement from equilibrium point. This point now, this is our point of maximum displacement. The distance from this equilibrium point to this point is called amplitude. The distance from equilibrium point to the point of maximum displacement is called amplitude. Another term is a period of simple harmonic motion. Now, don't forget, when you release this body from here, it will come like this to this point. That is toe, which is half circle. Then, and we said the movement on a straight line in to and fro manner. So it means to come like this, he just half of the journey. Then to return back like this, it has completed an oscillation, one oscillation. And then it means that's completed a circle like this. That is half circle. To come back like this, that is another circle, another half circle, making a complete circle. So to make a complete circle like that, the time taken for this oscillation to make a complete circle is called period. Therefore, if I want to calculate period, if I set this object into oscillation and I allow it to to make 10 complete oscillation, 10 oscillation, then I will now determine the time for how long to complete this 10 oscillation. If time is 5 seconds. Now, if I want to determine the period, and the period is what? Time taken for one oscillation. So I will just say this 5 over number of oscillation, 10. Therefore, my period T is equal to 5 over 10, which is equal to 1 over 2, which is equal to 0.5 seconds. 0.5 seconds. That is the period of oscillation. Once again, period of oscillation is what? Time taken for complete oscillation. One complete oscillation. Then, what of the next time there is frequency. So we talk about frequency. What is frequency? That is the number of oscillation completed in a seconds. Number of oscillation in 1 second. Therefore, if I come back here, number of oscillation in 1 second. In that case, my frequency will be what? Number of oscillation 10 in 1 second. That is oscillation per second over 5, which will give me what? This, that is 2. And the unit of frequency is what? Hertz. Itself. Very simple. If you look at it very well, so this one shows that the period is inverse of frequency, or frequency is what? Inverse of period. That is, they are what? Inverse to each other. You can say it means frequency is equal to 1 over t, or we say t is equal to 1 over f. So they are reciprocal of each other. That is that about relationship between frequency and what? Period. Now, let's go to energy conservation in a simple harmonic motion like this type of motion, or energy transformation. Then if you have an object performing simple harmonic motion, so this point is called equilibrium point. This point is called equilibrium point or mean point. This place is end. We call it end or maximum displacement, point of maximum displacement. At this place, if you look at it, the height of the bulb to the horizontal is equal to 0. So automatically, the potential energy of this, PE, will be equal to what? Is 0. Because in the formula of potential energy, we have mgh. Formula for potential energy, PE, is equal to mgh. So if h is equal to 0, everything will become 0. Now, as the body is now going like this, you can see the height will be increasing until the height will become what? Maximum A. So at this point, h is equal to what? Maximum. So if h is maximum, it means our potential energy is what? Maximum. Then, the body that's going like this, on getting to this place, it has to stop before returning back. By stopping, it means velocity is equal to 0. And if velocity is equal to 0, it means the kinetic energy, Ke, is equal to 0. Then, when you now release, the body is now coming back like this, the velocity will be increasing until it will get to this place where it will have what? Maximum velocity. So at this mean point or equilibrium point, velocity will be what? Maximum. So automatically, the kinetic energy, Ke, will equal to what? Maximum. It will be maximum here. So the point where potential energy equal to 0, the kinetic energy will become what? Maximum. The question now is this. At this point, we said the potential energy, at this point, we said potential energy is maximum. And that potential energy on getting to this place, it become what? Is zero. How come? Where is this energy that was maximum here before? How come it's now what? Zero here. Does it mean that energy has destroyed? No. It means the energy, that is potential energy here, has completely converted to kinetic energy here. So potential energy, likewise, potential energy here that is zero now is something. Then kinetic energy here that is maximum here, on getting to this place, it become what? Zero. What is happening? It does not mean that energy is destroying, but is converting from one form of energy to another. Therefore, the potential energy here at maximum, this one, that is mg8, where 8 is maximum, is equal to kinetic energy here, where velocity is what? Maximum. So we can now conclude like this. I say mv square over 2, where velocity is maximum, at this place is equal to mg8, where height is maximum here. So you may be asked to find velocity, maximum velocity. So in that case, m, we cancel m. Therefore, v square over 2 is equal to g8 with maximum height. Then maximum velocity here too. Then cross multiply. We have v square, where velocity is maximum, is equal to 2g8 with maximum height. Therefore, v maximum velocity is equal to square root of 2g8. Then take note of this formula. Square root of 2g8, it will be very similar to another formula you still come across under escape velocity. That one will have a square root of 2gr, radius of the earth, instead of 8. So we are going to stop here. This first part of the simple harmonic motion topic. The next topic will be based on velocity and acceleration of a simple harmonic motion.